Hello everyone, in this video we're going to be evaluating a radical expression. We have the square root of 2 plus square root of 3. And we're going to simplify this expression by writing it as a sum of two radicals. We've seen similar problems before on the channel, and I'll be presenting three methods. Let's see if you can guess all those methods. Probably you already know the first and the third one, but let's see if you can guess the second method before I present it. All right, let's get started with the first one. For my first method, I'm going to set this equal to square root of x plus square root of y. Now, that is our goal, to write this as a sum of two radicals. And after this, let's go ahead and square both sides. All right, great. Obviously, we want x and y to be rational numbers here. Now they're rationals. So when we square both sides, we're going to get 2 plus root 3 equals. On the right-hand side, I'd like to write the first and last terms together. So I'm going to write it as x plus y plus 2 times the square root of xy. So we kind of sort of expanded it. Now, from here, since x and y are rational numbers, we can go ahead and compare them in the following manner. X plus y needs to be at 2, and 2 times the square root of xy needs to be square root of 3. That gives us a system, and it looks like this. X plus y is equal to 2, and then 2 times the square root of xy is equal to square root of 3. If I square both sides, I get 4xy equals 3, and xy equals 3/4. I also have x plus y equals 2, so this is my system. Obviously, this system is quadratic. You can replace y with 2 minus x in the first equation, or y with x with 2 minus y, so on and so forth. But anyways, it's fairly easy. You can even guess this. And from here, and let's just assume or suppose that x is greater than y. It doesn't really change anything, but for convenience sake, if x is greater than y, then I can safely say that x is 3/2 and y is 1/2, because their sum is 2 and their product is 3/4. Okay, great. So now our assumption was that this expression could be written as square root of x plus square root of y. Therefore, now we can write it as the square root of 3/2 plus the square root of 1/2. And now we need to simplify this a little bit. Let's go ahead and add them with a common denominator, and then rationalize the denominator. Let's go ahead and multiply the top and the bottom by root 2. And obviously, we're trying to simplify this. So square root of 2 plus root 3 just becomes root 6 plus root 2 over 2. All right. And that ends the first method. Let's go ahead and talk about the second method now, and let's see if you already have an idea. All right. Second method. For my second method, any guesses? Let's see. I'm going to be using trigonometry. I know you guys some of you are probably thinking, like, where does trigonometry come from? Well, I'm hoping that some of you at least are familiar with the fact that tangent 15 is equal to 2 minus root 3, and tangent 75 is just 2 plus root 3. Okay, maybe you didn't know that, but we can go ahead and come up with that real quick. I can write this as tangent 45 minus 30. By the way, these are in degrees, but I don't like writing the degree symbol, so hopefully you'll forgive me for that. And by using the formula for tangent, what is that? Alpha minus beta, we can write this as tangent 45 minus tangent 30. You know the difference formula for tangent, 1 plus this and that. Now, tangent 45, this is tangent 15 on the left-hand side. Tangent 45 is 1. Tangent 30 is square root of 3/3, or you can write it as, you know, doesn't really matter, no big deal. I guess square root of 3/3 is fine. And then the bottom is going to be 1 plus 1 times the square root of 3/3. Here we go. Multiply the top and the bottom by 3, and you get 3 minus root 3 divided by 3 plus root 3. Awesome. Now we're going to rationalize the denominator here. And let's go ahead and multiply this guy here by its conjugate, which is 3 minus root 3, the top and the bottom. the numerator becomes the something squared, so it's going to be like 9 minus 6 root 3 plus 3 divided by 9 minus 3, which is, what is 9 minus 3? 6, okay, brain freeze. 9 plus 3 is 12, 12 minus 6 root 3 divided by 6, and this is tangent 15, by the way. It's going to become 2 minus root 3. Okay, great. So tangent 15 is 2 minus root 3. I was just trying to explain that. Now we're going to put this on a right triangle. Okay, let's make a right triangle as right as we can make it. Suppose this is 15 degrees. Okay, I wrote the symbol. And this opposite side, 2 minus root 3, and let this be 1. Now, you know the Pythagorean theorem, and I'm not going to go into details, but I think you can come up with this real quick. By using the Pythagorean theorem, you find that the hypotenuse is 2 times the square root of 2 minus root 3. Okay, and from here, here's what I would like to do. I would like to evaluate cosine of 15, and I'll tell you in a little bit why, or you'll understand why. So let me go ahead and do it here so I can save some space. Cosine 15 basically can be written as adjacent over hypotenuse, which is 1 over 2 times the square root of 2 minus root 3. And let's go ahead and do the same stuff we did before, which is rationalizing the denominators. So we're going to multiply this by square root of 2 plus root 3, and the same thing. Now cosine 15 from here becomes square root of 2 plus root 3, and at the bottom these two make 1, so we're going to end up with a 2. Okay, that is cosine 15. Now how am I going to use that, right, to evaluate our expression? Remember, our original expression was the square root of 2 plus root 3, and obviously we're pretty close to that, right? Okay, great. We just need to multiply by 2. Now here's what I'm going to do. I have a value for cosine 15, and then I would like to, you're not supposed to see the next page yet. I'm going to evaluate cosine 15 in a different way. How? By using the formula cosine 45 minus 30. And that is, cosine 45, which is root 2 over 2, times cosine 30, which is root 3 over 3, right? I'm sorry, root 3 over 2 it should be, not 3 over 3 is tangent something, whatever. Root 3 over 2 plus, remember with the cosine, it's the opposite. It's supposed to be root 2 over 2 times 1/2. It's the signs, Okay, so this gives us cosine 15 as root 6 plus root 2 over 4. But I also know that it's equal to the square root of 2 plus root 3 over 2. And from here, we're looking for this, yay. So square root of 2 plus root 3, if you multiply both sides by 2, you get root 6 plus root 2 over 2 as our answer. I know it's a very convoluted, complicated way, but it is a method. Okay, great. And let's go ahead and look at these numerical values. Now you can get to see them. Square root of 2 plus root 3, which is our original expression, is equal to that, and 2 times cosine pi over 12. By the way, this is in 15 degrees in 15 degrees. All right, 15 in degrees, and they're equal, obviously. Okay, great. Let's go ahead and talk about the third method. But first, let's take a look at the Wolfram alpha output as well. We have our input, the decimal approximation. As you saw here, this is much better, obviously. And the alternate form, if you rationalize, you're going to get the answer. And minimal polynomial, I hope you know what that means. If you don't, please comment and someone will answer that. Okay, great. Let's go ahead and talk about the third method. And I know text is being cut off, so I'm going to put that a little lower. So here we go. The third method is really cool. I love it. It's my favorite. And please let me know which one is your favorite. So anyways, so I'm going to couple this up with its conjugate and call this x. And then, the usual stuff. We're going to square both sides. And that gives us the first squared plus the second squared plus 2 times ab, which is 2 times 1. And when you multiply these, you get 1. Okay, great. So this is equal to x squared. Root 3 cancels out. X squared equals 6, which means x is equal to root 6. Awesome. This is not what we're looking for, but we're going to use this. Awesome. Let's go ahead and take a look at something similar to this, which is the difference. And I'm going to call that y, and don't ask why. So now we're going to square both sides again, and this time we're going to get 2 plus root 3 plus 2 minus root 3 minus 2. As you know, the product is 2ab. These two cancel out. Y squared becomes, and the 2's cancel out. Y squared becomes 2, which means y becomes square root of 2. Awesome. I got the value for x and y. Let's put it together. Awesome. So now we have a system. I overused the word awesome. I realize that, so I'll stop. 2 square root of 2 plus root 3 plus square root of 2 minus root 3. Remember, that is equal to x, and x is root 6, and their difference is root 2, which is y. And remember, we're trying to solve for the first expression, so it's kind of like eliminating, but remember, the left hand side, they are not variables, they are constants, but that's okay, that's perfectly fine. We can go ahead and add these up. We're going to get this guy twice, and that is going to equal square root of 6 plus root 2. If you divide both sides by 2, bingo, you'll get the answer. And this brings us to the end of this video, and also end of this document. As you can see, is a white space. Sorry about that, but anyways, this is the end of the video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.